In this video, I'm going to give a quick overview of stoichiometry, and then we'll take a quick quiz throughout the video. First, what is stoichiometry? Stoichiometry is a method that allows chemists to predict how much of a product will be made in a reaction. If we look at this reaction below, we're taking Na or sodium and adding it to Cl2 or chlorine, and we're making salt. Stoichiometry lets us predict how much NaCl or salt we would create. But the first step in any stoichiometry problem is to make sure we balance our chemical equation. For instance, if we have two of these aluminum atoms, remember that the 2 in front of aluminum shows us how many aluminum atoms. The 3 in front of this Cl2 shows us how many molecules of Cl2 there are. And the 2 in front of AlCl3 shows us how many molecules of AlCl3 there are. However, these numbers mean something else in terms of stoichiometry. Instead of representing atoms and molecules, these numbers in front of our balanced equation, 2, 3, 2, can represent the moles of each chemical. And this is going to be very important in predicting how much product we can create. So from this balanced equation, the same one on the last slide, we can find something called the mole ratio. And the mole ratio is the relationship between two different chemicals in a reaction. For instance, if I look at Al and AlCl3, I'll see there's a 2 in front of Al and a 2 in front of AlCl3. That means that 2 moles Al create 2 moles AlCl3. Similarly, I can look at Cl2 and AlCl3 and see that 3 moles of Cl2 creates 2 moles AlCl3. So the mole-to-mole relationship is given by this fraction right here. And finally, we could also compare reactants to each other. We could say 2 moles of Al requires 3 moles of Cl2 to fully react. It doesn't matter which chemicals we compare. When we're talking moles of one chemical to moles of another, we're comparing them using these numbers in front of our balanced equation. Notice that there are multiple mole ratios in any one chemical equation. Also, notice that any mole ratio can be flipped because it's just relating to chemicals. For instance, 2 moles Al over 3 moles Cl2 could be flipped. It's the same thing. These numerators and denominators, or tops and bottoms, are essentially equal to one another in our equation. And one more example, we could say 2 moles of AlCl3 over 3 moles Cl2, or 3 moles Cl2 over 2 moles AlCl3. It really doesn't matter which we do. So now you give it a try. What is our mole ratio for this equation relating moles of Na2O to moles of O2? Go ahead and answer on the EdPuzzle. You should have found that there were 2 moles of Na2O for every 1 mole of O2. Remember, we pull that mole-to-mole ratio directly from the balanced equation. Go ahead and try it out with this next problem. Find the mole-to-mole ratio for moles K2O to moles B2O3. You should have found there were 3 moles K2O for every 1 mole B2O3. All right, let's move on to the next question. One more time, our slightly more difficult equation. Use this equation to find the mole ratio between H2O and O2. You should have found the mole ratio was 6 moles H2O for every 15 moles O2. Now, in our next topic, let's look at actually setting up our equations for our stoichiometry predictions. Let's say we're going to perform this reaction given right here. And let's say we started with 35 grams of NH3. Our stoichiometry equation would be set up like this. First, we put the amount we know over 1. We know we have 35 grams NH3, so we'll set it up so that that amount is over 1. We then multiply by our second part, the molar mass of the reactant. So that's the molar mass of the NH3. We'll multiply by a fraction that relates the grams of NH3 to the moles of NH3. And we know from a previous section that 1 mole NH3 weighs 17.04 grams. The next thing we'll multiply is the mole ratio. That's what we did earlier in this slideshow. We know that there are 4 moles NH3 for every 6 moles H2O. Now, what we put on the numerator here is determined by what we're looking for. In this equation, if we were trying to find H2O, we would target H2O. And notice that we have 6 moles H2O to every 4 moles NH3, because that's what's in our balanced equation. And our last part, we're going to multiply by the molar mass of whatever product we're looking for, in this case H2O. We'll multiply by 18.02 grams H2O for every 1 mole H2O. Remember, 1 mole H2O weighs 18.02 grams, and we could get this number from the periodic table. Notice that I've color-coded this, showing that all units cancel with their neighbor crosswise. Grams NH3 cancels, moles NH3 cancels, moles H2O cancels, and we're left with grams H2O. Now, how would we actually calculate this? Well, after we acknowledge that all units cancel except for that last massive product, we could type this into our calculator. And the way we would calculate this is we'd start with our first value, 35. We would ignore any ones in the problem. We'd multiply by numerators and divide by denominators. So really, we'll start with 35. And in this first fraction, because the 17.04 is in the denominator, we're going to divide by 17.04. In our next fraction, we have a 6 in the numerator and a 4 in the denominator. So we will multiply by 6 and then divide by 4. We'll just do these one after another. And in our last fraction, we have 18.02 in the numerator. So we'll multiply by 18.02. Now, if you type this exactly as it's shown into your calculator, you'll get 55.52. What that number means is, remember, that last unit, the one that doesn't cancel, is the unit of our answer. It's 55.52 grams of H2O. We've predicted that if we start with 35 grams of NH3, we should create 55.52 grams of water. Now it's your turn. Just try to calculate this stoichiometry problem. I've filled it out for you ahead of time. Go ahead and try to calculate this out. What you should have gotten is 20.21 grams of Na2O. You should have typed in 15 divided by 22.99 times 2 divided by 4 times 61.98. Go ahead and try one more. Again, I've set up the problem for you. How would you calculate this stoichiometry problem? What you should have gotten was 202.61 grams AlCl3. The way you'd get that is you would do 41 times 26.98 times 2 divided by 2 times 133.33. Now in this problem, we're going to do this step by step. The first thing I want you to do is find the correct mole ratio, the blank spot in the equation here. What would we fill in for this mole ratio? You should have found that it's 3 moles K2O for every 6 moles K. Remember, we pulled that from our balanced equation. Next, go ahead and calculate how much K2O we would produce. What you should have gotten was 46.98 grams K2O. 39 divided by 39.10 times 3 divided by 6 times 94.2. Let's try this one more time with our last equation. Go ahead and first identify this mole ratio given here by this blank fraction. You should have gotten 12 moles CO2, as shown here in the equation, for every 2 moles C6H6. Now, calculate the amount of CO2 produced. You should have gotten 37.18 grams CO2, 11 divided by 78.12, times 12 divided by 2, times 44.01. And now one last question. What is the purpose of stoichiometry? Remember, why have we been doing all of this? What you should have said is stoichiometry helps us predict how much of a chemical can be created. That's the last of the presentation and quick quiz on stoichiometry.